moment. We're supposed to have 38 something, I think 36 students. We're short of more or less 10 students. Can you ask them to join?
Okay, doctor.
Thank you. Okay. For today, the topic for today's lecture is nutritional adaptation and homeostasis. All right. So, nutritional adaptation. What is nutritional adaptation? I let your friends. Okay. That's not. Okay. So, nutritional adaptation. So, according to Webster's dictionary, adaptation is an alteration or adjustment in structure or habit. So it's an adaptation in structure or habits. It is they are often hereditary, by which a species or individual improve its condition in relationship to its environment. So meaning that, you know, living beings are able to change their lifestyle, you know, in order or according to whatever that been given to them to get better suited to their habitat. So without adaptation, most of the living beings cannot live, cannot survive. So that's why it is very important to have nutritional adaptation in order to survive in their different living environment. So the way in which humans adapt to specific environment. This is the definition of nutritional adaptation or adaptation. Dietary adaptation. Dietary adaptation, this refers to how our body adjusts to certain food choice, because we have, thousands of different type of foods around the world, and how a person's body reacts to certain foods may depends on the culture they came from. Different people coming from different background, from different country, you know, different. We have different culture around the world, so depends on the culture. Our body will try to adapt. We'll have that to adaptation in order for us to adapt to survive on this culture that we are used to. All right, let's see on the major dietary transition along human history. So how actually, the human adapt to the changing environment. Right. This was, you know, this this was taken from this journal. So around, if you see, the scale is in million years, about 6 million years ago to around 4 million years ago. The human living in that era generally consume plant-based diet. So there's no data showing them consuming animal-based diet. So generally, they eat plant-based diet, and then after that, from 4 million years ago up to 2 million years ago, a hard and aggressive plant-based diet, and from 2 million years ago, you know, until and then they start to adapt to the different environment, the type of food that they can access. They start to have mixed type of diet, mixture diet from containing plant and animal because of the plant and animal domestication, monotonous and energy rich diet that they can have. So and then to have access to the animal based diet, they need they come out with an you know innovation of using stone tools and fire in order to cook the animal, to kill, to hunt the animal to get food. you know so this is how the journey of the dietary transition along human history. So how nutrition influences our body. So different human, different population, different area, not only we are not only eating different type of food, but our body, our cells, also kind of like different from one to another. So the digestive system, human digestive systems often use them in somehow different ways. Okay. It depends on the the locality, the area that they live on. So you can see here the picture on the right hand side here. People are living in a very cold environment, very cold area, such as in Alaska. Like this Inuit, the the people coming from this type of a region called Inuit, the Inuit of Alaska, living in northern Canada and in Greenland, they traditionally ate far more fat. Right, this guy here eat far more fat. They used to eat high fat diet most than most of other population in the world, and their gastrointestinal systems apparently capable of breaking fats down for use by their bodies. So I know maybe from this statement we can tell because their body needs to generate heat, right, in order to survive in this very extreme cold area. So they need more fat for the you know for their body to survive the heat, sorry, the cold temperature. So this is an indication that adapting to local nutritional opportunities has led to the evolution of related genetic differences among the population of the world. All right. Another example, some people or tribes in various part of the world have been described as having thrifty genes. So these thrifty genes, the term of thrifty gene coming from one scientist, I forgot the name, but this scientist came up with the term of thrifty gene for the people with that their body are unusually efficient at utilizing calories in their food. So meaning that these people at the some people that consider having thrifty gene, they have their body can utilize, can absorb, can utilize the calories from the food very efficient. So in order to provide for period of food shortage, subsequently need to consume less than other people in their size in order to maintain a stable weight. So these type of people, when they eat something, they can maybe, for example, when we eat rice. So in Malaysia, we used to eat rice, right? A plate of rice with one chicken and um, and a vegetable, right? One plate of rice, maybe it contains about 5 to 600 calories, right? 5 to 600 calories. When these type of people with a thirsty gene eat plate of um, a plate of rice with chicken and some vegetable on it, so they can efficiently take maybe 90% of the calories that the plate has to offer, about 450 calories from out of 550 calories of the plate. Okay, while for us, normal people, we don't have this kind of genes. Maybe from 500 calories of the one plate of rice, our body maybe can utilize, can take up to 300 calories. Because of I've been mentioned earlier that the body is not that 100% efficient in order in terms of absorbing or utilizing all the nutrient or calories that comes that we get from our fruit. Okay, so but these type of people, they have the ability to take as much as calorie that their body can. Maybe from 500 they take 450 calories. So because of this, you know they need to consume less food or less calorie compared to us, the normal people. Because if they eat as much as we eat, they get, they can get increase their weight very easy, very very quick, very fast. So in order to maintain their weight, they need to eat less food, because even though they eat less food, they still can have the same amount of calorie that we consume every day. Okay, so this is the area, Canadian Inuit, uh, Pima Indian, Yagan, Aborigines here, indigenous Siberia. So this type of you know people living in this area, very cool area, they have this type of gene. Okay, the Tohono O'odham, so or desert people, this type of people living in, or Native American people living in Sonoran Desert until 20th century. These traditional subsistence farmer, they are farmers. They are farmers for centuries. For maybe hundreds of years, they are farmers. From their great great grandfather, they are farmer community. So these traditional subsistence farmers had diet that mostly consisted of beans, squash, and corns. They used to eat just plant-based diet and very little animal protein and fat. Maybe they get milk from the cow, and so that they have slender to medium body build. So now in this century now, with the introduction of Western diet, you know what is Western diet, why Western diet is, right? So because of this Western diet introduction to them, obesity and type 2 diabetes are very common for most of them. So this is because of the dramatic change in that diet was responsible for this deterioration in health. So can you imagine if you used to eat, you have this thrifty gene, for example, right? But you used to eat plant-based diet such as beans, squash, and corn, and then suddenly after a while, because of the modernization, the introduction of Western diet, now you can access a different type of food. All right, so your body not really used to you know to have to consume that type of food, the Western diet, the modernization diet, and then it's like a kind of a shock to the body. Okay, so it gives, increase the risk of having obesity and type 2 diabetes in this type of people here, because they don't used to eat so much meat and fat. So the change of diet from traditional diet in favor of the fat and uh, protein-rich food, their bodies are responding to what for them is an excessive amount of calories. So in these beans, squash, corn, this type of fruit, they do not contain high amount of calorie. Okay, but they're fine with this type of people here, the desert people here. But after the introduction of Western diet, Western diet we have a high amount of calorie, you know, per serving. So by eating these type of people here, the excessive amount of calorie stored by their body, because their body can store very good at utilizing calories from food. So because of high calorie intake, they can easily get diabetes and associated type 2 diabetes. Okay, let's move on to adapting to alcohol. So not all people, have the same alcohol adaptation, because the genes are different from one to another, depends on the type of, the place or the localities in different area. Natural selection is largely responsible for population differences in the ability of humans to quickly metabolize alcohol in beverages and subsequently tolerate it. So adapting to alcohol more or less is a natural selection. Metabolizing alcohol eliminates its toxicity and remove it from the blood so that it won't cause cell and organ destruction. So for those, for the people, that in alcohol, their body need to metabolize this alcohol in their liver in order to convert it to the to non-toxic, and remove it from the blood. Because if the body does not metabolize it to the non-toxic, so it can cause toxicity and for cell and organ destruction. Okay, frequencies of the alleles in the two genes family ADH and ALDH, you know, coding for the enzyme involved in this protective process vary significantly from population to population. So not all people have the same, you know, gene in their body, especially for these two genes, family ADH and LDH, that relate to the metabolizing alcohol process that metabolize alcohol. So these two enzymes responsible in metabolizing alcohol in our body. So there is a wide range of variation in how rapidly and effectively alcohol metabolism occurs. For example, whether people become intoxicated easily and how long this state continue. It all depends on these two genes here. So beers and wine, the alcoholic beverages consumption have been common in Europe for 5 to 6,000 years. So this, for centuries, people in Europe have been drinking beers and wine or alcohol containing beverages. So this you know, um, made their body more adapted to this type of beverages. So medieval Europe, for example, they consume people living in this area here. They consume beer and wine were far more frequent than water. Can you imagine that people drinking alcohol frequently than water? So they need to have some sort of ability in their body in order to adapt adapt to this alcohol. Otherwise, it's going to be very dangerous for their body. So it is not surprising that many people in this population now have the genetic makeup that gives them a relatively high tolerance to alcohol. So you know that European people, some of the American people, they used to drink alcohol, and when they drink alcohol, they don't have much of the effect of the intoxication due to alcohol consumption, right? So in contrast, alcohol tolerance is unusual among Native American population. The Indian Native American population, they don't used to drink alcohol in their history, right? From their great great grandfather, they don't used to drink alcohol. Only had alcohol-based beverages since the arrival of European or British people when they arrived in America few hundred years ago. They introduced bring along their alcohol with them. So not until that time the Native American are exposed to alcohol beverages. So the time is too short for nature to select for gene combinations that would allow them to metabolize alcohol quickly. So all of these, because of the natural selection, so the time is too short since the European arrived in America up to now. The time is too short compared to the these 5 to 6 thousand years, right? So alcohol-related problems such as cirrhosis of the liver, liver disease, are at comparatively high rates among many Native American groups. So they don't use to, their body, the genes still not yet adapted to the alcohol, consumption. So they can have this a lot of liver problem because the alcohol will need to get metabolized in the liver. If the body not used to metabolize alcohol, alcohol will you know damage the liver. All right. So they are at a genetic disadvantage when it comes to consuming alcohol compared to European people. So next, lactose intolerant. I'm sure all of you know what lactose intolerant is, right? Maybe some of us have lactose tolerance. The best documented differences in nutritional adaptation. This relates to milk sugar or lactose, which is commonly found in uncooked dairy products. So lactose can cause lactose intolerance for certain people. For example, here a liter full full fat cow's milk contains about 650 calories, of which 250 are from lactose. So out of 650, 250 are from lactose. And most human adults have moderate to severe difficulty in digesting lactose. So because of this, they experience bloating, stomach cramp, belching, flatulence, and even diarrhea when they drink milk. Because some of us have lactose intolerant, we cannot consume lactose. Adakah anyone here have lactose intolerance? The problem when you drink milk, you have this kind of problem, or all good?
All
I'm
good at
okay.
that.
Good, all of
Good.
you. Okay, so you don't have, maybe we don't have this lactose intolerance, all right? Okay, due to an inability to produce sufficient amount of the enzyme called lactase, this enzyme responsible to convert lactose. This enzyme in the small intestine to aid absorption in the bloodstream. So without this enzyme, the individual can have lactose intolerance. Production of lactase is controlled by LCT gene on chromosome 2. Okay, this lactose tolerant, when the people consume milk containing lactose, right? And the milk end up in small intestine, for, for the normal people who's not lactose intolerant, they have lactase in their body. So this lactase will, will convert lactose into glucose and galactose. So no problem, so no problem in their body, such as bloating, stomach cramp, belching, and so on. And for those who considered as having lactose intolerant because they don't have lactase, because their body cannot produce lactase enzyme in the small intestine. So when they consume milk containing lactose, lactose will cannot be converted into glucose and galactose, and lactose will straight away, you know, end up at large intestine. Lactose will arrive at large intestine without broken down into the monomers of you know, carbohydrate monomers. So these lactose, because in our large intestine, there's millions of bacteria, right? So these bacteria in the large intestine will ferment this lactose and producing gas and organic acids. So this type gas will cause bloating, stomach cramp, and belching, flatulence, and even diarrhea. So this is how, you know, why for those certain people when they drink milk, they can have this type of problem because of the inavailability of the lactase to convert lactose into glucose and galactose. Majority of babies, can digest their mother's milk. So the beauty of the creation, because if the babies uh, couldn't digest the mother's milk, so the babies will have problem. The babies will not grow uh, normally, right? So the majorities of the babies can digest their mother's milk, but production decline as people grow up. Okay, when some adults, they used to have this type of enzyme in their body, but when people grow older, okay, uh, our body, somehow cannot be able to, to produce this lactase anymore. So it begins by 2 years of age. For some people, the reduction in lactase production does not start to occur until they are around 20. So some people, starting from 20s, the body started to not producing lactase anymore. So this lactose intolerance is at its highest frequency in some part of Africa, East Asia, and among Native American. The Northern European generally have the lowest frequency of this dietary problem. Northern European, because they used to drink milk, right? Only 1/3 of adults can digest milk. So based on from this statement, only 1/3 of adults can digest milk. The rest stop making the enzyme needed to process milk sugar. So at the beginning, more than 1/3 of us can digest milk, and then when we grow up, right, uh, our body, some of us, the body stop making the enzyme of lactase. So we are no longer able to convert the lactose into glucose and galactose. Advantages of particular food. Fava beans. So we don't used to fava bean in our country. So fava bean common in Mediterranean, right? So this fava bean can cause severe hemolytic anemia following fava bean consumption due to deficiency in glucose 6-phosphate dehydrogenase or 6-PD and X-linked enzyme. So because of this, deficiency of this enzyme, glucose 6-phosphate dehydrogenase, so individual with the deficiency of glucose 6-phosphate dehydrogenase, when they consume fava bean, they can have severe hemolytic anemia. It's quite dangerous actually. But fava bean consumption by individuals who are not G6PD, they may increase their resistance to malaria. So it's fava bean consumption by individuals who are not G6PD deficient, okay, may increase their resistance to falciparum anemia. In vivo evidence reported data showing that Anti-malaria action of favabin is lacking, but in vitro evidence supports the hypothesis of the beneficial effect of this favabin. So um, if you don't have the problem with G6PD deficiency when you eat favabin, right? So you can prevent from getting malaria, at least as as far as in vitro evidence shows us. But not yet in vitro evidence not yet being reported. Alright, so ada ke in this class, any of you ada yang G6PD deficiency? In my tak ada. In my family, my brothers have G6PD, so he cannot eat favabin. Favabin ni apa nama dia? Apa in Malay, kacang parang. Tahu tak? Do you know kacang parang? All of you? Tak tahu? Anyone know what kacang parang is? In Malaysia, we call it kacang parang, and the name in English is favabin. So if for those who have G6PD cannot eat kacang parang, so can have hemolytic anemia and other type of symptoms. Okay, now we done with the a few examples on nutritional adaptation, about alcohol tolerance, lactose intolerance, about the different type of food such as fava bean consumption and so on, about the thrifty genes we have discussed. So now we are going to see, we're going to look at homeostasis. So homeostasis is the ability of the body to maintain a condition of equilibrium within its internal environment when dealing with external changes such as regulation of body temperature. Our body, we need to have equilibrium or homeostasis in order our body to work properly. Okay, all the process of the function of body works properly by having equilibrium. The liver, the kidney, and the brain, these three organs here, hypothalamus, autonomic nervous system, and endocrine system, helps maintain homeostasis. These all the organs that are very important to maintain homeostasis in our body. So the liver is responsible for metabolizing toxic substance and maintaining carbohydrate metabolism. As for the kidney responsible for regulating blood water level, regulate the water level in our blood, reabsorption of some nutrients into the blood, reabsorption of substances into the blood, and maintaining salt and iron level in the blood, as well as regulate blood pH, and the most famous function of the kidney is excretion of urea and other waste. All right, these five here are the main function of the kidney. Regulate water levels in our blood. So if the nutrients, our body, lack of deficiency of some nutrients, the kidney will reabsorb the nutrients rather than excrete them. And then the kidney also help in maintaining the salts and iron level. If the salts level is too high, the kidney will remove it, excrete it. If the iron levels are so high, the kidney will excrete them. If the salts is too low, or like iron level is too low, the kidney will reabsorb them. By doing this, the kidney regulates the blood pH, and kidney excretes the urea and other waste, so that we remove all the toxic component to prevent toxicity in our body. So the brains As for the brains produce number of hormones that are responsible to maintain the body homeostasis. First off, we see how the body controls the temperature. Okay. As we know that all mammals maintain a constant body temperature, right? So humans, we as a human being, our body temperature is about 37 degrees. If our body is exposed to hot or cold environment, we need to maintain it at the temperature of 37. Okay. This is how to maintain the proper function of our body process. For example, here when your hypothalamus senses that you are too hot, okay, when the body exposed to very hot environment, hypothalamus will send signals to your sweat glands to make you sweating, and by sweating cools your body off. Okay, so this is how the brain hypothalamus maintaining the body temperature at 37. If it's too hot, our body will sweat, produce sweat and cool the body down. So when the hypothalamus senses that too cold, it sends signal to the muscle, so muscle that make you shiver and create warmth. Hypothalamus sends signal to the muscle, so saying that maybe okay, the body is too cold, starts generate some movement or shivering of the muscle, creating heat and create warmth for the body and maintain the body temperature at 37 degrees. Okay, what else? Okay, here the brain is a control center. The brain here upside here too hot, the sweat glands, the skin, so blood vessel dilating and sweating. Right, response heat release from the body. By sweating, we release the heat from the body via the sweat, right? And then release heat from the body, blood temperature drops, negative feedback signal via blood, and homeostasis. If it's too cold, signal to skin via nerve. It's too cold, signal to the skin and the muscle blood vessel constriction. Blood vessel constriction. This here, if too hot, blood vessel dilating. If too cold, blood vessel constricting. Blood vessel constricting, move away, um, you know, from the move the blood vessel away from the skin, and then also causing the muscle to shivering and metabolic rate increasing, heat conserved or produced, oh, and then blood temperature rises, the homeostasis. So the first mechanism to cool the body, sweating. The sweating is when your body is hot, sweat glands are stimulated to release sweat. The liquid sweat turns into a gas, when it evaporates, it turns into gas. To do this, it needs heat. In order to turn the liquid sweat into gas, you need heat, right? So it gets the heat from the skin. As your skin loses heat, it cools down. So this is the skin. So now the body temperature is increasing. Okay. So the skin, so the skin produce the sweat, our body producing sweat, and the sweat will be removed from our body via skin. Right? So it will evaporate and the body temperature will drop. Mechanism to cool the body, we call it as vasodilation. So this vasodilation is the widening of blood vessel. Okay, vasodilation is the widening of the blood vessel results from the relaxation of smooth muscle cell within the vessel wall. Your blood carries most of the heat around your body. We know that, there are blood vessel capillaries all over our body, right? So this blood carries heat energy. There are capillaries underneath the skin, underneath the skin of our body. There are capillaries that can be filled with blood if you get too hot. So this brings the blood closer to the surface of the skin so that more heat can be lost. So this is why, for certain people with a fair color of skin, they look red when they are hot. Okay, for us as Malaysian people, we have different tone color compared to our some of the Caucasian, Chinese, from Malay, Indian, we have different tone of colors. Maybe we couldn't see, when our body turns into red. But for some people, Chinese, Caucasian, when they get hot, we can see it clearly because their face can turn into somehow, red color of skin because of the hot. So this is how it looks like. So if the temperature rises, the blood vessel dilates meaning that the blood vessel gets bigger, so more blood, filling the vessel here, and this blood carries heat from all of our body. In order to remove the heat from our body, they need to bring this heat closer to the skin. So, this one is small blood vessel and fill it with more blood containing carrying heat. This means more heat is lost from the surface of the skin and the body temperature drops. So this is how our body maintaining our body temperature when we get too hot. So the mechanism to warm the body. If we are very cold, our body needs to increase the body temperature. The first, vasoconstriction. So vasoconstriction is the opposite of vasodilation. Vasodilation is the blood vessel becomes bigger, capillaries under your skin become bigger. But for vasoconstriction, the name is constriction. The capillaries under the skin gets constricted or shut off. We don't want the blood to get too near to the surface of the skin, underneath the skin. So this takes the blood away from the surface of the skin, so less heat can be lost. Right? If the temperature falls, the blood vessel constrict. You can see previously it's huge. Now it's getting, the blood vessel constrict, and less heat is lost from the surface of the skin because there's not much blood carrying heat to be removed. So the temperature of the body will increase. Next, body shivering. So when the core body temperature drops, below 37 degrees, for example, the shivering reflex is triggered to maintain homeostasis. How do we do that? So this is caused by rapid muscle contraction and relaxation. They are the body's ways of producing heat when it feels cold. So muscle groups around the vital organ, we have, around our organ, we have muscle surrounding all the vital organ. So these type of muscle around the vital organ will begins to shake in a small movement, not much. In small movement. Sometimes we didn't even realize the movement of this muscle because it's a very small movement. By doing this, expending energy, creating heat to 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 increase the body temperature. So most often, when the purpose of muscle activity is to produce motion, the heat is wasted energy. The heat is a wasted energy, but we need this because in order to maintain the body temperature or the homeostasis of the body temperature. Number three, huddling. So everyone knows what huddling is, right? So huddling is for warmth. You can see here the chicks here, they huddle together to freeze their body temperature. And then one more example, penguin. Penguin in Antarctic, right? Penguin in Antarctic during the winter season. This is how it looks like during winter season when the temperature of the airway is, extremely cold, can be up to -40, -50, and something like that. So huddling behavior in emperor penguins. So emperor penguin in a huddle during winter to preserve warmth. Normally, penguins are very territorial. They need they're not used to work in a group like this. But during the winter season, um, they do this by huddling together in order to survive during Antarctic winter. Antarctic winter can be extremely cold. I don't know, maybe -70, -50. I don't know. We can ask Dr. Aklima. She's been to Antarctic a few times. Maybe she knows how cold is there. I don't have any idea because I know it's very cold. In my experience, I've been to Arctic Circle, just the border of Arctic Circle in Lapland of Finland. I've been there for 2 weeks, and it's very cold. That's Arctic temperature. And at that time when I was there, and during the day, the temperature was about -15. For me, it's very cold during the day, 12 o'clock or 1 o'clock in the afternoon. The temperature was -15. In the night, about 7 p.m., the temperature drops to -25. So I cannot even go out of the um, of the hotel. No, not the hotel. It's like kind of like a small resort in the middle of Arctic jungle. I tried to go out one day to capture northern lights, but I cannot even stand there for 1 minute. It's very cold. It's -25. So I cannot imagine what this like in Antarctica, because Antarctica very cold compared to Arctic. So this is how penguin ways of surviving during Antarctic winter by huddle together to preserve the warmth of their body. Huddling helps warm the penguin because they transfer heat between individuals. So the temperature inside a huddle can be as high as 35. So in the middle of the huddle can be as high as 35. Can you imagine the surrounding temperature environment during Antarctic winter, maybe -40, something like that. But in the huddle, in the middle of the huddle, can be as high as 35. It's very high. Scientific measurement and calculation have shown that by huddling together, emperor penguin use about half the energy that they would otherwise. So by doing this, they only use half of their energy. They can preserve their energy so they can survive the extreme Antarctic winter. So maybe some of you might question what happened to the penguins uh, that are outside of the huddle, right? So for the penguins that are in the middle of the huddle, they're fine, they are happy because the temperature is high. But the penguins outside of the huddle, what happened to them? So they are very clever. There is a constant changing of position from the outside to the inside during a snowstorm lasting days. So the whole huddle will slowly move a couple of 100 meters or more. So they keep changing the position. They are very smart. They don't let their friends die. They change the position, from maybe this guy here. They already been in the middle of the huddle for for a day, they will move outside and then let the others take his position, and that's how they do until they survive the winter storm of the Antarctic winter. Number four, to warm the body, the process is called piloerection or pilomotor reflex. This pilomotor reflex is bristling of hairs due to involuntary contraction of small muscle at the base of hair follicle that occurs as a reflective response to the sympathetic nervous system, especially to cold shock or fright, or we call this as goosebumps. Goosebump, right? When you have goosebump, the hair of your body will stand. Okay? This is when the hair of your skin stands up. So erection of the hair of the skin due to contraction of the tiny adductors pilorum muscle. So the hair traps a layer of air next to the skin, which is then warmed by the body heat. The air becomes an insulating layer. So when the body temperature decreases, when the body temperature decreases, right, the hair, the hair in our body will stand up, right? So the reflex produced goosebump, cutis, and serina is known as a raising piloerection or pilomotor complex. Okay, so now we done with the homeostasis of the body temperature. Now we move on to how our body controlling the glucose level. This is one of the most important homeostasis in our body, controlling glucose level, because high glucose level related to obesity, diabetes, insulin resistance, and so on. So it is extremely important to control the glucose level in our body. So this is how the flow of to maintain the glucose level in our body. So the hormone of energy expenditure. Beta cells. We know that beta cells in pancreas produces insulin, right? Beta cells produces insulin. So leptin here on the left hand side here, leptin is a hormone produced mainly by adipocytes. Adipocyte is fat cells. Fat cells produce leptin. So this leptin involved in the regulation of body fat. So leptin interacts with area of brains that control hunger and behavior, which then sends signals the body has enough to eat. So inhibit hunger. All right. So leptin, okay, interact with areas of brain to control hunger. So when we have we already full, okay, our body, we already eat our dinner. For example, buka puasa kan, we already break our fast. We eat a lot, nasi kerabu, whatever, and then we are full. And then our body will produce leptin. This leptin is the hormone that tells the brain, so that the brain tells our body to stop eating. So because we have enough, all right. So by producing leptin, send signals to the body by via the brain, tells the body that we had enough to eat. So it stops us from eating. Okay, another type of hormone, CCK, cholecystokinin, a polypeptide hormone, stimulates the contraction of gallbladder with release of bile and the secretion of pancreatic enzyme into the small intestine. And ghrelin, another hormones that we call it appetite stimulating hormone. Ghrelin is the opposite of leptin. Leptin is to suppress the appetite, to make us stop eating, while ghrelin make us eating. Appetite stimulating hormone, it stimulates us to eat. GIP, glucose independent insulinotropic polypeptide. GLP, glucagon-like peptide 1. So glucagon, as we know, is a hormone produced by the pancreas that, along with insulin, control the level of glucose. So um, when stomach is empty, right? When the stomach is empty, ghrelin will be produced. Okay, so that it says to it sends signals to the brain to make us eating because it's a appetite stimulating hormone. So when the stomach is stretched, secretion stop. Okay, it acts on hypothalamic brain cells both to increase hunger and to increase gastric acid secretion and gastrointestinal motility to prepare for food intake. Okay, when especially now when we are fasting, now our stomach, we don't have food in our body. We don't have liquid because we cannot drink, we cannot eat, right? For Muslim who are fasting. So the body, in our body at the moment, our body now producing ghrelin. Ghrelin asking us to eat, but we couldn't eat until until we are allowed to eat around Maghrib time, right? So body producing ghrelin. Ghrelin is a appetite stimulating hormone. When the body produces ghrelin, okay, it increase hunger. Okay, that's why we feel very hungry. Okay, because of the ghrelin, and then it increase gastric acid secretion. This ghrelin also increase the gastric acid secretion, the production of gastric acid in the stomach. Okay, it's like kind of like and increase the gastrointestinal motility. This is all how our body prepare for the food intake. So by having ghrelin, now the gastric acid secretion is high, gastrointestinal motility is there. So when we eat, our body already ready to to digest whatever food that we eat because we already have gastric acid, gastrointestinal motility also there. So this is how our body uh, you know send signal and we are about to eat by producing ghrelin. Again, bear in mind ghrelin is the opposite of leptin. Leptin is when we eat too much, leptin will be secreted by by our body by the fat cells to stop us from eating more. So controlling glucose level, insulin, glucagon. So this is two main hormones that are responsible controlling glucose level in our body. Fasting blood glucose is to monitor blood glucose normally in millimoles per liter. If the fasting blood glucose level below 7 is safe region. Okay, any of you pernah check your fasting blood glucose level? Tak pernah? Ke pernah?
Tak pernah.
Tak pernah. Maybe you should check. Nowadays because of the diet that we eat, all processed food, you know, um, banyak minum, air sweet drink, right? Air semua manis-manis. So maybe once a while we need to check our blood glucose level. So if the fasting blood glucose level is below 7, it is the safe region. If fasting blood glucose level is 7 to 10, it's a gray area, right? This is where you need to pay attention. But if the fasting blood glucose level is above 10, this is dangerous, considered very dangerous because it's already exceeded the level of the that considered safe. So more than 10 is dangerous. I hope all of us below 7. So fat state. Now fat state. Fat state meaning that we already have food. We are full now at the moment. 8 o'clock tonight. Most of us Muslim dah buka puasa kan. We all consider fat state. Fat states. If there's too much glucose in blood because we already eat, we are full now. Dah buka puasa, we eat some different type of foods. kuih, air, whatever kan, ayam percik, whatever. So there's too much glucose in the blood at the moment. So insulin stimulates glucose conversion to glycogen, liver and in the muscle. So you see here, now the glucose in the blood, there's a high level of glucose in our blood. So the insulin stimulates this glucose conversion to glycogen. So less glucose in the blood because it's been absorbed, been taken up by uh, by the cells. So insulin takes, responsible to take the glucose from the blood and convert it into glycogen in the liver and in the muscle for storage. So this figure here showing, glucose concentration and time after meal eaten. Okay, glucose level rise after meal. Glucose level rise after a meal, and insulin is produced. Insulin is produced during this time here, and glucose level falls to normal again. This is how our body maintains the blood glucose level. Insulin transport of blood glucose into cells where it can be used as energy is responsible to transport blood glucose into cells where it can be used as energy. So insulin also responsible to store, responsible to increase the storage of glucose as glycogen in the liver and muscle or as fat in adipocytes. Some of glucose in the blood will be stored as a glycogen in the liver and muscle, and some of the glucose can be used, to produce adipocytes. Can insulin drive obesity? Someone, maybe answer this question. Can insulin drive obesity? So this is the question that I want you to find yourself, right? Can insulin drive obesity? I will ask some other time, but make sure you find yourself the answer. Can insulin drive obesity? All right. So glucose uptake in muscle and fat cells is regulated by insulin-stimulated exocytosis of membrane vesicle containing GLUT4. GLUT4 is the is the protein that takes the glucose from the blood into the cells. The name of the protein is GLUT4. So glucose uptake in muscle and fat cell is regulated by insulin-stimulated exocytosis of membrane vesicle called GLUT4. Okay. On insulin withdrawal, the process reverses itself through endocytosis. So this is how it looks like when there's glucose. When there's glucose, the GLUT4 will be translocated into the membrane in order to bring the glucose inside the cell. Without glucose, if there's no glucose, okay, for example, the glucose is not here, there's no glucose here, so this GLUT4 actually within the cells here in the cytoplasm of the cell. All right, when there's glucose, the body sense that there are glucose available, the GLUT4 will be translocated into the cell membrane and ready to take the glucose. This is how the process of taking glucose from the blood into the cells by GLUT4. Insulin index. Insulin index had always been assumed to go up and down with the blood glucose level, which led to glycemic index, assumed to be surrogate measure of insulin level. I'm sure that most of you heard about the term of glycemic index, right? What is glycemic index? Please find out what is glycemic index. You can just, that's when you buy, for example, bread, for example, rice. Then some rice says that 5.5 glycemic GI index. GI is glycemic index. Why it's 5.5? When you buy, for example, apa beras mahal tu, basmati, for example, Faiza basmatis, whatever basmati, you can read at the back of the rice packaging. It says 5.5 GI or whatever number of GI, and what it actually tells you. Ke semua beli je kan, semua beli je beras kan, tak check pun. Okay, now you can beli yang murah. So okay, that's why the expensive rice such as basmati, they have stated the GI. If you go to market today, just go to the rice section, you take the most expensive, or not most expensive, you just take one rice there that, at the turn the packaging, you see at the back the GI, and whatever number, you Google what the number tells you about the GI and what is important. Okay, it has something to do with the insulin index. Insulin index based on blood insulin level. Okay. How much insulin the body normally release in response to a whole food or meal. So its carbohydrate and the quantity and quality of its protein and fat. Insulin index responds to various foods. Certain foods such as lean meat and protein cause an insulin response despite there being no carbohydrate present, while some foods cause disproportionate insulin response relative to their carbohydrate load. Normally, when when the food contains high amount of carbohydrate, the insulin index will high. Okay, now we move on to fasting state. Now, at the moment, we are in fasting state for most of us, right? At the moment, if you see here, glucose in our blood is very low. Now it's about 5 p.m. It's even lower, right? So if there's not enough glucose in the blood, glucagon stimulates breakdown of glycogen into glucose in the liver. So what our body needs to do now is converting this glycogen, hydrolyze this glycogen into glucose, because the glucose in our blood is very low. We need glucose in our blood because, such from, for example, our brain's source of energy is glucose, right? So our brain really needs glucose. So what our body needs to do, hydrolyze this glycogen, convert it into glucose. So glucagon break down glycogen, and now the blood fill up with more glucose. So the glucose in the blood can be transported into peripheral tissues that require glucose for energy, such as brain. So during fasting, liver glycogen levels are depleted. So muscle glycogen also falls down. Backups energy supply needed through other means. How do our body can get these energy supplies from? The first one, amino acids are recycled to be broken down for glycogen through gluconeogenesis. You know that gluconeogenesis generate glucose from glucogenic amino acid, right? So first method, by having glucogenic amino acids via gluconeogenesis, producing glucose for our body. Second method, increase hormone to drive lipolysis. Lipolysis is the hydrolysis of the fat in our body for fat immobilization to produce energy from body's fat. So meaning that our body hydrolyze the fat, called lipolysis, the process called lipolysis, and hydrolyzing fat producing energy from body's fat. Body undergoes a low metabolic rate during fasting. Now, our body undergoes a lower metabolic rate Urinary nitrogen excretion falls due to less catabolism of muscle protein. Okay, this is how what's happening in our body as we speak. Okay, because we just, what time is it? 10:21 a.m. Okay, this is how it looks like in our body at the moment for Muslim people who are fasting now. And then gluconeogenesis, generation of glucose from, siapa boleh jawab? From what? From siapa? Anyone? Generation of glucose from, sorry?
Non-carbohydrate compounds.
Non-carbohydrates, such as
Pyruvate.
pyruvate, lagi lactate, what else? Glycerol, and glucogenic amino acids. So glucogenesis takes place mainly in the, kat mana?
Liver.
Liver, and to a lesser extent in the cortex of kidney. So other substrates, glucogenic amino acid as well as citric acid cycle intimidates the latter through conversion to, kat mana?
Oxaloacetate.
Acetate. All right. In humans, the glucogenic amino acids are blah 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 blah. Blah. There are number of glucogenic amino acids. Glucogenic amino acid is the type of amino acid that can be used in gluconeogenesis to produce glucose by converted to pyruvate or TCA cycle intermediates such as oxaloacetate. Apa lagi ke? You still remember this list here? Oh, fats. Hot chain fatty acids also can be oxidized to yield propionyl CoA, a precursor for succinyl CoA, which can be converted to pyruvate and enter gluconeogenesis. So some type of fats, such as hot chain fatty acids, can be used to produce glucose via gluconeogenesis by converting them to pyruvate. Okay, via the precursor of succinyl CoA. Not all fats, the odd chain fatty acids. The even chain fatty acids cannot be used to produce glucose via gluconeogenesis. Hydrolysis of fat in the fat cell produce fatty acids and glycerol. Glycerol can be converted to glucose as well. So gluconeogenesis from glycerol is just a recap of, you already learned this before. Glycerol phosphate, DHAP, dioxyacetone phosphate into glucose. This is how we convert glycerol to glucose. Okay, so this on the top hand side here, fat state. Okay, fat state. We already eat. Glycogen synthesis, lipogenesis. We call glycogen synthesis and lipogenesis to generate fat cells. Lipogenesis and glycogen synthesis for energy storage. Insulin receptor. Insulin also responsible for glycogen synthesis in muscle. GLUT4 take glucose from the blood into the cells and store them as glycogen. Or insulin also responsible for lipogenesis and producing, generating fat tissue or adipocyte. In the fasted state, glucagon glycolysis, fatty acids hydrolysis. Glucagon responsible for conversion of glycogen to glucose via glycogenolysis. Glycogenolysis is the process of conversion of glycogen Okay, sorry about that. My laptop suddenly turned off. I don't know why. Sorry. Okay, it's good to have all of you still here. Boleh dengar kan? Can you still hear me and see the slides properly?
Boleh, Doktor.
Boleh, Doktor.
Boleh, Doktor.
Alright, sorry about that. My laptop actually, the battery dah problem, so I don't know why. Sometimes they turn off suka-suka hati dia je. Okay, let's continue. Okay, I think we done this, right? Okay, we already discussed this. Alright, let's see about on the abnormal levels of blood glucose. Abnormal levels of blood glucose, if it's high, we call it hyperglycemia. Hyperglycemia or high blood sugar. High blood sugar is an excessive amount of glucose circulates in the blood plasma. Blood glucose level greater than 7 when fasting, is the borderline. We want, you remember, below 7 is the most. Blood glucose level greater than 11 2 hours after meals. Above 7 millimole per liter is generally considered to have diabetes. So meaning that if you are fasting, but your blood glucose level is higher than 7, it's something that you need to uh, pay attention because it's considered to have diabetes. While chronic level exceeding 7 can cause organ damage. For example, 11, 12 can cause organ damage. And normally, when we are fasting, the blood glucose level is normally less than 7, 5.5, for example, 6. And then if, above 7 is considered to have diabetes. For diabetes patient, the blood glucose level is normally above 7, while exceeding 7, up to 11 here can cause organ damage. For hypoglycemia, low blood sugar level is called hypoglycemia. So when the blood sugar level is below 1, this is where it's really dangerous and leading to coma. Why is it like that? Because we know that the brain, the only source for brain energy for brain is glucose. So when there's very low level of glucose in the blood, we cannot supply the brain with the glucose, and then the brain cannot generate their energy. And then when that things happen, it can lead to coma and brain damage. Abnormal levels of blood glucose can also, because due to the damage of the pancreas cannot produce insulin. So because there's no insulin in our body, our cells cannot take the glucose from the blood. So pancreas does not produce enough insulin. And the second scenario is insulin resistant. This is what normally happen for most of the diabetic patient, which called type 2 diabetes. When there is insulin, but the body does not respond to the insulin. We call it insulin resistant, or insulin sensitivity is reduced. So for example here, pancreas pancreas produce insulin, there's good amount of insulin being produced, but insulin receptor in our cells cannot sense the insulin that are being produced by the pancreas. So because of this, even though there are high amount of insulin, but the receptor cannot sense the presence of insulin. So the cells the blood flow cannot take the glucose from the blood into the cell. So the glucose remain in the blood, and when the glucose in the blood is too high, it can cause toxic to the blood. And that's what happened in type 2 diabetes patient. So cells do not respond to insulin that is produced. Again, diagram here, when the meal eaten, glucose level rises. Glucose levels rise after meal. Okay, this is normal when we eat. All the carbs from our diet will be converted into glucose, simple sugar. So it's normal that the glucose level will rise after meal. Insulin is not effective. There's insulin production here. Somewhere here, there's insulin being produced by the pancreas, but our body cannot sense this insulin. So we call it insulin insensitivity. The sensitivity of insulin is reduced, or it's not there. So insulin is not effective, so glucose level stays high. This is called diabetes. Okay, again, the blood glucose in the glucose in the blood is increases. So that's the level of glucose in the blood is high. Okay, what we need to do, our body need to do, is to convert this glucose to glycogen, right? That's the the process that our body needs to do now, because the glucose in the blood is high, it increases. But there's no insulin to stimulate glycogen synthesis. No insulin here to take this glucose and produce glycogen, stored as glycogen. So glucose concentration keep increasing in the blood to the dangerous level, so even higher amount of glucose, because we keep eating, right? After a while we eat something again, but there's no insulin to convert the glucose into glycogen for glycogen synthesis in the liver and muscle, and the level of glucose keep builds up in the blood, so it can reach to dangerous level and can cause toxicity in the blood. Abnormal level of blood glucose. Abnormal level of blood glucose can be categorized as, we call it as chronic hyperglycemia. Chronic hyperglycemia levels more than slightly above normal can produce very wide range, a variety of serious complications or over a period of years. This includes kidney damage. Why kidney damage? Because kidney need to excrete all of this glucose in the blood, because too much glucose in the blood will try to send all this glucose to the kidney, and the kidney need to excrete them. But because of too much glucose, after a while, after a period of years, the kidney can get damaged, because the burden of the kidney is increasing. We don't want to burden the kidney too much, right? Can cause neurological damage because of glucose is not stable. It can cause toxic effects to our neuron. Cardiovascular damage. So this is one of the most common things that can happen to diabetic patient. Damage to retina or damage to feet and legs. So this is called diabetic retinopathy, because high amount of glucose. This glucose from the blood, because the blood carries all the glucose. The blood vessel near to our eyes, contains high amount of glucose. It can damage the retina. Diabetes mellitus. Diabetes mellitus is related to disease related to high blood sugar levels over prolonged period of time. There are about 4 types of DM, but the most common one is type 1 and type 2. Type 1 results from autoimmune destruction of insulin producing beta cell in the pancreas. So meaning that type 1 is when the pancreas or beta cells in the pancreas is damaged. So there's no beta cells, or the pancreas are not able to produce insulin. You know, type 2 diabetes mellitus is the most common diabetes mellitus. Type 2 diabetes mellitus. This is due to insulin resistance and lack of insulin. It can caused by the pancreas, level of the insulin produced by pancreas is very low, and most of the time the level of insulin being produced by the pancreas is okay in a good amount, but the body cannot sense the insulin. We call it as insulin resistant. This is the most common diabetes type of diabetes, type 2 diabetes. Okay, there are gestational diabetes, diabetes, when people during pregnancy, when the baby is born, after a while, they don't, the mother will not have diabetes anymore. So, but, and diabetes mellitus causes, what can cause diabetes mellitus? It is either hereditary or lifestyle disease. So normally, the world that we are living at the moment, more or less, majority, the main concern is on the lifestyle, because the type of food that we eat, high sugar food, simple carbohydrates, you know, too much sugar in our drinks and so on. Diabetes mellitus also can cause obesity and lifestyle, lack of activity, physical activity. Again, not only diet, the physical activity, the lifestyle. This is all about the lifestyle. Nowadays, maybe 50, 30 years ago, when we were kids, 20 years ago, the internet is not, 20, 30 years ago, the internet is not that, you know, normal, right? As you know, especially in Malaysia, we don't have that internet connection. We don't have social media. We don't have phones. Most of us just, in order to kill time, we go out, we play with friends. We do a lot of physical activity. We keep playing in the morning. We play with our friends in the evening. We playing with friends. And then we go home, and then you know, we resting at home. But nowadays, because of the changing of lifestyle, everything's made easier nowadays. We have phones, we have games, social media, and so on. Especially for kids that really into tab, small kids, children that rely on tabs, every day, because they don't used to go out playing with friends anymore, especially nowadays because of the pandemic COVID-19 for 2 years plus now. You know. So the lifestyle is extremely different from what we used to have back then, right? So this can cause a lot of problem for for our generation. And so not following a balanced diet. So the symptom can be frequent urination, increased thirst, intense hunger, blurry vision because of the diabetic retinopathy, nerve damage such as electrical dysfunction. So this is all the classical symptom of high blood sugar. Okay, um, I think I'm going to stop here, because next is the body control of water level. I don't think we have enough time to finish all. Might as well I just stop here, and we going to discuss a new subtopic next week on Monday, right? Okay. Any question from the class before we end our lecture? No.
Doctor.
No. No. Ada ke tak? Any question? If not, okay, we can stop now. Thank you very much, and happy fasting, and stay safe to all of you. All right. kan, tak ada question. Ada ke tak ni? Semua tak keluar pun.
Ada.
Okay,
Thank you, doktor.
Thank you.
Thank you, doktor.
Bye.